Hi everyone, you're gonna have to bear with me today for day 3's lesson. I don't have a clean copy of this, so I'm just gonna be using my answer key the whole time. Day 3 is on what's called the normal distribution. The normal distribution has to do with what we call the normal curve. So the normal curve is something that's used to describe a whole lot of things. For example, something that's familiar to you would be like your height and weight. So if you go to the doctor and they tell you, your height's in the 10th percentile or the 90th percentile, that gives you an idea of how many people are taller or shorter than you. So the idea is based upon the fact that, our average is like the middle, okay? So this right here in the normal curve, the average is the middle. That's where the bulk of people's, heights and weights are. Okay, and then as we know, some people are really tall and some people are really short, okay, and same would go for weights as well. So the normal curve just says, hey, whatever is the average, we put that right at the center, okay? Whatever's above average, that's a bit more rare. Whatever's below average is a bit more rare. Now let me just tell you what these numbers mean. So in the normal curve, when you are 1 standard deviation away above or 1 standard deviation below the mean, that's what the ones mean, standard deviations. That means there is 34% of the data in a normal distribution would be above, and 34% would be below 1 standard deviation away. So if you add those two 34s up, the majority of data, guys, lies within 1 standard deviation away. It's 68% of the data. Now, if we go 2 standard deviations away, again, this is what the 2's are for, the standard deviations, that tacks on an additional 13.5% approximately. These numbers are approximate. If you Google normal curves, you'll see a bunch of different possibilities. So if I add on from 68, add on an additional 13.5, that'll account for 95% of the data. And if I add on just a little bit more over here to get to 3 standard deviations away, add 2.35 in each direction, that would come out to 99.7% of the data. And you can see the final 0.3% of the data lies above 3 standard deviations away. So we've kind of already answered some of the questions below, but let's go to it. If I want to know what percentage of the data lies within 1 standard deviation of the mean, within 1 standard deviation could mean 1 above or 1 below. So I'd have to add up these 2% to give me 68%. Within 2 standard deviations, again, that's within 2 above or 2 below. So you have to add up all 4 of these. It gives you 95. So this one just says more than 3 standard deviations away from the mean. So more than 3 would be bigger than 3. So 0.15 in this direction, 0.15 in this direction, adds up to 0.3. Between 1 and 2 standard deviations above the mean. So between 1 and 2 would just be between this region right here, between 1 and 2, 13.5. Okay, and there's a variety of questions I could ask similar to that, but that just gets you an idea of how to use the percents and how to add them up. Okay, so in the next exercise, you just stop and read over the question. Whenever I see a question that's talking about normally distributed data and I have the mean and standard deviation, I automatically make my own curve, okay? And so at the center, the mean or the average is right here at 540. And then how did I find these other numbers? I added or subtracted the standard deviation. So from 540, I added 80, added 80, added 80. In this direction, I subtracted 80, subtracted 80, subtracted 80. And so again, if this is my average right here, this is 1, 2, 3 standard deviations away above, and this is the minus indicates 1, 2, and 3 standard deviations below. So for part A, we want to know what percent of the scores fell between 460 and 320. Now that I've got this diagram, it makes it easy. Between 460 and 320, that's between 1 standard deviation below and 1 standard deviation above. So look above to our chart. If I'm 1 below or 1 above, that's 34 and 34, 68% of the data. So that's the first answer. But then there's a second part of the question that says how many students is this? Well, 68% of 424 students would be calculated like this. Just change the percent to a decimal, multiply by 424, and that's 288 students. that fell in that area. So part B, what's percent of the scores fell between 380 and 620? 380 and 620. So that's 2 standard deviations below, all the way up to 1 standard deviation above. So 2 standard deviations below to 1 above, I'd add 13.5, 34, and 34. 81.5. In part C, if Suzanne scored a 700, what percent of the students who took the exam did better than her? So if she did 700, she was right at the second standard deviation. So right at the second standard deviation, there's 2.3 plus 0.5% of the population that did better than her. These are the people that are above her or did better. And so if you add those numbers up, you get 2.5%. And again, how many students is that exactly? Well, change 2.5% to a decimal, bump the decimal point 2 places over to make 0.025 times 424 is 10.6, but we can't have 10.6 students, so it's 11 students. On to the next page. Okay, so using that table on the front side is nice. However, sometimes you just don't have that table there, and it'd be one more thing to memorize. If you have the table with you, it's easy to use, but if you don't, it's kind of a pain in the neck. So there's a function in our calculator that's going to help us to figure out those percentages in the same manner, okay? So instead of us finding the 68% by using the table we did in the front side, now I'm going to show you a way to use it in your calculator. So I'm going to skip right to exercise 3, and then I'll go back to what's up at the top there. So we have the heights of 16-year-old teenage boys are normally distributed. Again, that tells me to make a normal curve. We've got the mean, we've got the standard deviation, okay? So I made a normal curve. I put the mean at the center. The standard deviation is 3, so I add 3 to go 1, 2, 3 above. I subtract 3 each time to go 1, 2, 3 standard deviations below. Now we've got the student Jabari that's 72 inches tall, and so that means he's falling right here at 72, which is at the second percentile above the mean, okay? So it says here, which of the following is closest to the height of his percentile rank, okay? Now we could go to the back side of this paper, the front side, excuse me, and use that table, but again, that would require you to memorize the table. We don't want to do that. That's a bit time consuming. There's a lot to know there. So there's a feature in a calculator, normal CDF is what's going to look like, that we can use to figure out how many students he's taller than. So what we're going to do, I'm going to show you how to get there first. In your calculator, if you have a TI-84, second, VARS, this guy right over here. Option 2 is norm CDF. And then we got to enter some information here. A lower limit, an upper limit. This right here is going to be the average, okay? And this number is going to be the standard deviation. All of that is right here in your notes. Once you do norm CDF, you type in a lower, an upper. I'll tell you what that means in a second. The mean and standard deviation. Okay. So in this question, we want to know his percentile rank. So we want to know how many people is he taller than, okay? So the lower limit would be something really low, anything lower than what's 57. So to make life simple here, instead of just trying to think of a number smaller than 57, if you're looking for a lower limit, look for something really low, like just do negative 9999999, okay? I could do even 0, and I would get the same answer as a lower limit. But for consistency's sake, if that helps you out, you can always do, like I said, negative, a bunch of 9s, okay? The upper limit, the max is 72. That's the highest we want to get to. So that would be 72. The mean is 66 inches. The standard deviation is 3. Now, you go down to where it says paste. Press enter over paste, and there you go. That is your percentage as a decimal. You could multiply it by 100 if you want to see the actual decimal. So, to answer this question, his height is in the 98th percentile. That's what's closest to 97.7. Okay. Now, if for some reason you can't find this norm CDF in your calculator, what you can do is do second catalog, which is down here, the 0 button. And then once you're in the catalog, you're automatically in alpha mode. So to find norm CDF, you could just press N here. See that green N? It'll take you to the M's. And then you could find norm CDF that way. Okay? And then you'd have to just type in the lower limit, you know, negative 9999999, the upper limit 72, the average 66, and the standard deviation 3, and so you get the same answer. Okay? Exercise 4. Amount of soda in a can is normally distributed, so automatically I'm thinking normal curve. The mean is 12, right there at the center. Standard deviation is 0.6, so I add 0.6 to go above. I subtract 0.6 to go below. There's 250 soda cans that were pulled by a company to check volume. How many would be expected to have less than 11.4 ounces in them? So if it's less than 11.4 ounces, okay, here's 11.4. We want to know what's going to be less than that, okay? So if I go to norm CDF, second VARs for me, norm CDF is option 2. I can actually keep that negative 99999. I could also choose something just much lower than 10.2. Negative 500 works. Negative 600 works. It just has to be much smaller than this lower limit, okay? And like I said, for consistency's sake, I'd choose that. Now, if I were looking for an upper limit that would go up to infinity, I would just use positive 9999999, or something, again, much larger than that number. Okay, so then we have the upper limit to be 11.4. It's a max we want to go to. The average is 12. The standard deviation is 0.6. Go to paste and enter. And again, if you want to multiply 100 just to see it as a percent, you can do that too. 15.86% will be approximately 16%. And now I want to know specifically, though, how many cans are there. So if I want to know 16% of the cans, 0.16 times 250 is approximately 40 cans. Okay. In case you're wondering, that's actually a very real scenario. Many companies will check their machines to make sure that they're producing things properly, potato chips, whatever it is that they're making, and they randomly select bags of chips or soda cans or whatever to make sure that it's meeting their standards, also known as quality control. So we will actually do a little bit more of this on day 4, okay, a little bit more specific next time. But you can go ahead and do your day 3 homework. And again, we skipped day 2. Have a good one.